Guys, you got your review sheets out? So we're picking up where we left off yesterday. So we got to number 20, but I don't think we got to number 21 yet. So when adding or subtracting rational expressions, we want the denominators to be the same, because if they are, we can add or subtract the numerators. Now, it really doesn't matter what the denominators are as long as they are the same. If they're the same expression, we can add or subtract them together. Now, there are three here, but all three of the denominators are the same, so we can add and subtract, or here, just add the numerators together. So since all three denominators are 3x plus 2, we can add our numerators. If the denominators are the same, we can add or subtract the numerators. Now at this point here, we can combine like terms. So 9x squared doesn't have any like terms, so it's just going to be 9x squared. 6x plus 6x is going to be plus 12x. And negative 1 plus 5 is going to be plus 4. So again, the denominators, as long as they are the exact same, we can add or subtract the numerators. If they're not, we have to make them be the same. Here they were already the same, so we can add the numerators together. And after we did that and combined like terms, we get to our 9x squared plus 12x plus 4. Now, before we can say that this is the final answer, we need to make sure that nothing on top or bottom factors. Well, the denominator is already factored 3x plus 2, but our 9x squared plus 12x plus 4 will factor here. Now, there is not a greatest common factor because we do need to look for greatest common factors first. Now, since the third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of the first term, 9x squared, well, we would have x and x. And our factors of 9 are 1 and 9 or 3 and 3. Now, if something's going to match up in top and bottom and simplify out, we're going to need to match it up with the 3x plus 2. So hopefully the 3x, 3 and 3 would be the factors of the first term that we want. So 3x and 3x. Factors of 4, 1 and 4 or 2 and 2. Because if these do work, we will have a common factor of 3x plus 2 on top and bottom that would cancel. And we can check and make sure. 3x times 2 is 6x. 2 times 3x is another positive 6x, giving us the positive 12x middle term that we wanted. Now we can simplify 1 on top and bottom. That leaves us with 3x plus 2. Since it's on top, we don't have to put over 1, but if the 3x plus 2 had been on the bottom, we would have to put 1 over the 3x plus 2. All right, guys, focus. Questions on this so far? Yeah. So 22, x squared minus 5 minus x plus 3 over x plus 7. Now, there are some of the problems on the test that are already factored. Now, if they'd have given us this problem in this form already, it's factored. We don't have to do anything with it. We don't have to factor it. It factored it for us. So there are some of the problems on the test that are already factored. So you don't have to do any factoring to solve them. But here, since the denominators are both not factored, we have to factor them first. Now our x squared plus 5x minus 14 will factor. There is not a greatest common factor. But since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 14 are 1 and 14 or 2 and 7. All right, guys. 7 and 2 are going to be our factors, and we're going to want the 7 to be plus and the 2 to be minus to get that positive 5x middle term. So if the test had factored it, we're really starting here, not starting at the top, because it already factored. Now, since the denominators aren't the same, for us to be able to add or subtract, we would need to get the denominators to be the same. Now, they both have an x plus 7 in common on bottom, but the one on the right has an extra factor of what? X minus 2. So for the denominators to be the same, I have to multiply the one on the right by x minus 2 over x minus 2. Because when we do this, the one on the left, the denominator is still x plus 7 times x minus 2. The one on the right, we have the x plus 7. And when I multiply it by that x minus 2 on bottom, the denominators are now the same. Because again, once the denominators are the same, we can add or subtract the numerators. Now the denominators are the same. We do have the same two factors. So it means we can, in this case, subtract the numerators. But before we do that, we are going to have to multiply out this x plus 3 and x minus 2. Now the x times x is going to be x squared. X times negative 2 is negative 2x. 3 times x is going to be plus 3x. So 3 times negative 2 is negative 6. Now we will need to combine like terms. On the right-hand side, our negative 2x plus 3x is going to give us plus x minus 6. Now looking at this here, are the denominators the same? Yeah, they both have the same set of terms. So if they gave us a problem starting here, all we have to do is subtract the numerators. So, since the denominators are the same, and it's going to be x plus 7 times x minus 2 on top, we can subtract the numerators. Now this time we put parentheses around it because, again, one of the tops has more than one term. And that negative is going to have to be applied to everything in that set of parentheses. Now the first set of parentheses, there's nothing in front of it, so it's going to stay positive x squared negative 5. But here our positive x squared is going to become negative. Our positive x is going to become negative x, and our negative 6 is going to become positive 6. And lastly, we need to combine like terms. Our x squared minus x squared is going to become 0, because x squared minus x squared is 0. Negative x does not have any like terms, so it's going to stay negative x. And lastly, negative 5 plus 6 is plus 1. All right, guys. Focus in.
Here's the name. Let's come to the office. Here's the name. Let's come to the office.
All right, guys, focus, focus, focus. So, we need to see if there's anything in common. Now, even if we factor the negative out of the top, there's nothing going to be in common on top and bottom, so this is as far as we can take it. Questions on this here? Because again, the whole goal with addition or subtraction, if the denominators aren't the same, we need to make them be the same. Questions on 22? Yes, sir. Yes. Now, there's not going to be anything like 23 where we have 3 different bottoms of the fractions. There's only going to be 2. So most of the problems are going to look like 22, not 23. So we can come back to it if we do have time. Yes. Huh? Helps if you pay attention.
I was, but like it went up and then went down, and I lost the thing.
Because the whole goal was to get the denominator the same. Once they are, we can add or subtract the numerators here. It's telling us to subtract. So we subtract, combine like terms, and simplify. And if the denominators are already the same, because even if we give them a problem starting at this point here, we just subtract. The denominator is the same. Even though it's not a single term, 2 sets of parentheses, it's still the same. All right. Least common multiple. We're looking for the first expression that we can make the given expressions be the same as. If we have time, we can come back to it. Now, looking at 26, we do have 2 terms. And we need to factor each of these terms as far as they possibly can go, and then we're going to try to get them to be the same. 2x squared is as simplified as it gets. It's a single term, nothing else we can do to it. 4x plus 12, does it have a greatest common factor? And that would be 4. And we can factor the 4 out of 4x plus 12, giving us 4 times x plus 3. Least common multiple. Now, some of the nicer places to start is with our sets of parentheses. Now, the one on the right has a factor of x plus 3. Since it shows up once in that one, none in the other, we need it once, listed once in our least common multiple. Now we need to look at our numbers outside the parentheses. So we have 4 and 2x squared. Well, the 2 has an x squared, the 4 doesn't, so we do need x squared listed once. Well, it has 2 x's, the other has 0 x's outside, so we need 2 for the least common multiple. Now, 4 and 2, we're looking for the first number we can make 4 and 2 be the same as going up. Now, unfortunately, 2 is not going to be the least common multiple. It will be the greatest common factor between the 2. 4. Yeah. So 8 is a common multiple of 4 and 2, but it wouldn't be the least, the first one. So it can be equal to one of them. Yep. So 4 doesn't necessarily have to go up, but we are going to match the bigger one. It could be equal to the bigger one or bigger than it. Since we can turn 2 into 4 by multiplying it by 2, we get that there. Let's look at 27. X squared plus 3x minus 40 and x minus 8. Now the x squared plus 3x minus 40 we do need to factor. Now there isn't a greatest common factor between those 3 terms. Always look for a greatest common factor first. Now since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now our factors of 40, 140, 220, 5 and 5 and 8. And it'd be 8, positive 8 and negative 5. Least common multiple. Well, we can start off with our one of these factors. Let's say x plus 8. So for our first expression, x plus 8 shows up as a factor. In the other one, it shows up 0. So we need it how many times? Once. And we also do need an x minus 5 because it does show up as one of the factors once. Doesn't show up as a factor in the other one. Is there anything else we need? X minus 8. So the least common multiple for this here ended up being everything, x plus 8, x minus 8, and x minus 5. Because each one of those factors showed up in one of the two expressions once. Questions on 27. Let's look at 29. So we're going to need to factor these two. We're going to start off with 4x squared minus 16. Is there a greatest common factor? 4. So we'll start off by factoring it out. So if we factor a 4 out of 4x squared minus 16, we get 4 times x squared minus 4. X squared minus 4 is going to factor to what? X plus 2 and x minus 2, it's our difference of perfect squares. Will it factor further? No. No other common factor between our x plus 2, x minus 2. The degrees 1, so that's as simplified as it gets. Let's look at our 6x squared minus 24x plus 24. Is there a greatest common factor? 6. We'll factor it out. If we factor the 6 out, we get 6 times x minus 4, or 6 times x squared minus 4x plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared are x and x. Now the factors of 4 are 1 and 4 or 2 and 2. The factors that we want are 2 and 2. Least common multiple. Now again, we can start off with our parentheses first. Let's say x plus 2. The one on the left has the factor x plus 2 once. The one on the left has it once. The one on the right has it 0. So how many times do we need it? Once. Now the one on the left has x minus 1 or x minus 2. The one on the right has it. So how many times do we need it? Whichever one has the most. Because it does show up 3 times total, but we're looking at which one has the most. Since one of them has it twice, we need it twice. Because for the one on the left, even though it does have it once, I can multiply it by another, and it now has 2, and will match. So we've taken care of all of our parentheses. Now we're left with 6 and, so we're trying to see what is the first number going up that we can turn 6 and 4 into. Well, yeah. Because 4, if we did the skip counting, 4, 8, 12, 16, 20, 24, 6, 12, 18, 24. 24 is a common multiple. It's just not the least common multiple. So the least common multiple for this is 12 times x plus 2 times x minus 2 times x minus 2. Again, you will get points for at least factoring them correctly or getting most of it. It's not all or nothing. So questions on least common multiple. I'll come back to it if we have time. If you do want to make sure and check your answer, there is answers on there. Yep, so I include all those there so that you can check your answer to make sure you got it right. Yes. I will say also, if you know for certain you did it right and it disagrees with that answer sheet, ask. there is a chance the answer sheet is wrong. I think by this point I got most of those out of the answer sheet, but there's still a chance I did address it and I never fixed it. So 31 or 32, is there one of these two that y'all want to see worked out or have questions on? Okay. Let's do 31. So we need to figure out what we need to multiply this through by to get the fractions to simplify down. Well, if we multiply through by x plus 6, here this denominator in this term, will cancel. But the other fraction didn't. We need to multiply it by 2x. Now here the 2x and 2x will cancel, leaving us with 4 times x plus 6 is equal to our 2x times 5. Well, 2x times 5 is 10x. Now, one thing I will say before we start multiplying through is make sure the denominators are factored as far as they possibly will go. Because if there is any common factors, we need to make sure we're not over multiplying. Questions on this so far? Now at this point here we need to solve for x. So we're going to distribute the 4. 4 times x is 4x. 4 times 6 is 24. Is equal to 10x. Now since we don't have an x squared term, we just need to get the x's by themselves. So the next thing we can do is minus 4x, subtract 4x. 10x minus 4x is 6x is equal to 24. And lastly, we would divide by 6. Yes. So x is equal to. Now there is a question, so restrictions. There are 2 on the test that will have restrictions that you do need to be careful with. Luckily, if you read the instructions, I will say in the instruction, make sure to check your answers. Those, I would look back at the restrictions and make sure you're listing them. The rest, the restrictions aren't going to come into play. So again, our restrictions are whatever is going to make the denominator be 0. So here, it'd be what's going to make 2x be 0 or x plus 6. So for here, our restrictions would be 0 or negative 6. Because if one of the solutions was 0 or negative 6, we would throw it out. We'd cross it out. Questions on 31? Questions on 33 or 34? One of those that y'all want to look at. 34. Focus in, guys. Now with this one here, we need to make sure all the denominators are factored as far as they possibly can go. Because it'd be very tempting to want to multiply everything by x plus 1 and x squared minus 1. But the x squared minus 1 can be factored. Because x squared minus 1 is a difference of perfect squares. Which means it'll factor 2, x plus 1 and x minus 1. So if we had multiplied everything by x plus 1 and x squared minus 1, we would actually multiply the entire equation by an extra factor of x plus 1. Now let's see what we need to multiply through by. Well, we can start out by multiplying through by a single x plus 1. If I multiply everything by x plus 1, the 1 on the left, x plus 1 on bottom, will cross out with it. In the middle, the x plus 1 and x plus 1 will simplify out. The 3 does not have a denominator, so it's not going to simplify. It's just going to be 3 times our x plus 1. Do we still have anything in the bottom of any of the fractions? We have an x minus 1, which means we also have to multiply everything by x minus 1. So we can take it a single expression at a time. So here the x minus 1 and x minus 1 will cancel. So what that leaves us with is 4x plus 1 times x minus 1 is equal to 12 plus 3 times x plus 1 times x minus 1. Questions on this here? So really all we've done so far is multiply the whole equation by x plus 1 times x minus 1 to get rid of our fractions. Now at this point here we're going to have to distribute. So on the left hand side 4x times x is going to be 4x squared. 4x times negative 1 is going to be negative 4x. 1 times x is going to be plus x. And 1 times negative 1 is negative 1. Now, before we multiply the 3 on the other side, we will need to multiply our 2 sets of parentheses first. And it would indeed be x squared minus 1. Because where did we get the x plus 1 and x minus 1 from? Well, we got it from the bottom of our middle one, which was actually the factors of what? X squared minus 1. Off to the side, I can show you this here, because x times x would give us x squared. X times 1 would be plus x. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. And our x minus x in the middle would become 0. If we notice 2 of the factors that we're multiplying together came from one of the ones above, or previous page, we can just replace it. So at this point here on the left-hand side, we can combine like terms. Our negative 4x plus x is negative 3x. On the right-hand side, we're going to have to distribute that 3. 3 times x squared is 3x squared. And 3 times negative 1 is negative 3. Any other like terms? On the left-hand side, no, but our 12 and negative 3. 12 minus 3 is what? Positive 9. Questions on this here so far? All right, guys. Now, since we do have x squared terms, we have x to the power greater than 1, we need to get this equal to 0. Now, the first place I would start is by moving the x squared terms. So we'll subtract 3x squared from both sides. Now, on the right-hand side, we would get 9. On the left-hand side, 4x squared minus 3x squared, x squared. Now, the reason I would move the x squareds first is on the off chance that the x squared terms will cancel out. Because if they canceled out, we don't have any x squared terms left, we just have x. We get it by itself and solve. But here we still have an x squared term, so we still need to go through getting this equal to 0. So we'd subtract 9, telling us that x squared minus 3x minus 10 is 0. At this point here, all the problems on the test, all the ones solving on the test are factorable. You're not going to have to use the quadratic formula on any of these here. Now, since the 10 is negative, our signs are opposite. Factors of x squared are x and x. Factors of 10, 1 and 10, or 2 and 5. But 2 is positive, 5 is negative. And these would indeed be the correct factors. Now, since we do have two things multiplied together to equal 0, one of the two is going to have to be 0, either x plus 2 or x minus 5. So we can set both of them equal to 0 and solve. X plus 2, well, we would subtract 2, telling us x is equal to negative 2. X minus 5, we would add 5, telling us x is equal to 5. And those would be our two solutions. Questions on this here? Questions on 35 or 36? I want to look at one more. I want to look at 38. Because most of these here, once we get the denominators factored, we multiply through and solve. Now 38, we will have to factor one of our denominators. And whenever we're factoring the denominators, again, first place we need to look for is greatest common factor. X squared plus x minus 6 does not have a greatest common factor. So we'll have two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now the factors of 6 are 1 and 6 or 3 and 2. It's going to be 3 and 2. Because if it was 1 and 6, it's not. We would actually have to multiply through by 3 factors because we'd have the x minus 2, possibly x plus 1, x minus 6, depending on the sign. This is kind of nice, and these are the factors. So again, before solving, make sure to factor them completely. It will make them easier. Now this one here, we are going to look at the restrictions. Now the restrictions are whatever going to make the denominator be 0. So we're really looking at all the factors at the bottom of the fraction. So x plus 3 and x minus 2 are our two main ones. X minus 2 does show up in 2 spots, but the value of x that's going to make it be 0 is going to be the same for both of them. Now x minus 3, we would subtract 3, telling us x cannot be negative 3. For x minus 2, we would add 2, telling us x cannot be 2. So if we get positive 2 or negative 3, we will cross that solution out. Now let's see what we need to multiply everything by. Well, we can start off with x plus 3. And on the left-hand side, the x plus 3 and the x plus 3 we multiplied it by will cancel each other out. And that's the only one it'll actually cancel with. Now the x minus 2 is also needed. And again, the far left one, the x minus 2 and x minus 2 will cancel. And on the far right, the x minus 2 and x minus 2 will cancel. I like a little bit of most things. Anything Miss McClendon cooks?
No, what? That went real dark.
All right, guys. So we multiply through and get this here. Questions on this so far? From the original one. Now the next thing we can do is multiply through. Now even though we do have 2 times x plus 3 times x minus 2, I would do the parentheses first and then multiply the number last. So with this here, we'll distribute the x. X times x is going to be x squared. X times negative 2 is going to be negative 2x. 3 times x is going to be plus 3x, and 3 times negative 2 is negative 6. Yeah. All right. Now we also need to multiply the x plus 3 and x minus 3. Well, x times x would be x squared. X times 3 would be plus 3x. Negative 3 times x would be negative 3x. And negative 3 times 3 would be negative 9. Questions on this so far? Now at this point here, we're going to start combining like terms. Inside our first set of parentheses, the negative 2x plus 3x is going to give us a positive 1x or plus x. Now our second set of parentheses, we'll still have the x squared, but 3x minus 3x is 0. So we'll just have x squared minus 9. Now at this point here, we can drop the parentheses because there's nothing in front of it besides the plus, so we don't really need the parentheses there. Last thing we need to do before we can really start getting everything on the same side is distribute the 2. 2 times our x squared is going to be 2x squared. 2 times x is going to be 2x. And 2 times negative 6 will give us negative 12. Questions on this so far? Are there any like terms on the right-hand side? Yeah. So the negative 5 is by itself, but the 2x squared and x squared will combine to give us 3x squared. 2x is by itself, but our negative 12 minus 9 is going to be negative 21. So we get 3x squared plus 2x minus 21. We do have an x squared term, so we need to get this equation equal to what? 0. So how can we do that? Add 5, yes. So I have to add 5 to both sides. So when we add 5 to both sides, we get 3x squared plus 2x minus 16 is equal to 0. Now this will factor. Since the third term is negative, our signs are opposite. Factors of 3x squared, well, we would have x and x. 3 and 1, so 3x and x. Factors of 16. 1 and 16. 2 and 8. 4 and 4. 4 and 4. We can start there. We can check and make sure 3x times negative 4 is negative 12x. 4 times x is plus 4x, giving us negative 8x. Is that the middle term we wanted? No. So we can go to 2 and 8. One 51. Yep. Guys, let's finish this because this is the last problem we're looking at.
Sit down.
So when we check this one here, 3x times negative 2 would be negative 6x. 8 times x would be plus 8x, giving us the positive 2x that we wanted. Now at this point here, we would set both of these equal to 0 to solve for the value of x. For our 3x plus 8, we would subtract 8 from both sides, telling us 3x is equal to negative 8. Divide both sides by 3, telling us x is equal to guys, not quite done. I need to add 2 to both sides for x minus 2, telling us x is equal to 2. But that is a restriction, so we have to throw it out, telling us negative 3/8 is the only solution. If you do have any other questions, please let me know. We're starting the first part tomorrow.